Let us solve a problem on permutation and combination today. So the question is, in how many ways can we seat m men and n women where the condition is that number of men is more than the number of women in a row for a photograph if no two women are to be seated adjacent to each other? I hope you have understood the problem. So the problem is that you have more number of men than the number of women, and you want to calculate the number of ways, right? We can seat these m women and m men and n women in a row for a photograph, right? And the condition is that no two women are to be seated adjacent to each other. So try solving this. Pause the video. I hope you have tried solving this problem on your own. Now let us see the solution to this problem. The problems on permutation and combination is kind of always it's interesting for me to solve. So let us see the solution. There are a number of ways in which one can think about the solution. Now let us see how we are going to, or how I am going to approach the solution, right? When Einstein used to think about any problem, most of the times I've read that he used to do some kind of a thought experiment, right? So let us try doing that today, kind of a thought experiment of how many, to count the number of ways we can seat m men and n women in a row, right? So here, what I will do is suppose that the chairs are not arranged, right? It's like most of the times when we start to think about this problem, we think that chairs are already there. See, the number of chairs here will be how many? It will be like there will be total m plus n number of chairs will be there, because there are m men and n women, so m plus n number of chairs will be there. And we most of the times think of in this context we think, chairs are already arranged, we are just trying to occupy those chairs by these number of men and n women we have. So we are trying to occupy them in these places. But what we shall do now is that we shall say that everyone, like m men and n women, have their own chairs, and they are they are carrying their chairs with them. So it's not like chairs are already being arranged in a row, but it's like they have their chair with them, and whenever I ask them to come and sit, they will come with their chair and they will sit, right, in a row. So now what I will do at first is I will ask these young men to come first and sit in a row, right? Now you see there are how many possibilities, in how many ways they can come and sit, and I will ask them to sit in such a way that they have to leave space for one more chair in between them. What I mean by that is, when I ask them to sit, suppose someone comes, like let he's the first man, m1, right? Then I want him to leave a space, this m2, I want m2 to leave a space for one chair, and and let him occupy the second one, right? This position. So in that way I want them to sit. So let us suppose that m3 will sit here and so on. Then let us suppose here that m is sitting, it's a bad notation, but you understood, you understood this particular thing. M1, M2, M3, and MM. Number of the first men, second men, third, fourth. Again, we don't have any numbering of men. So how many ways can this sitting arrangement is possible? If you think it's actually m factorial ways. I mean, I think it's really obvious. The first position can be occupied by m men. The second position can be occupied by m minus 1 men. So there are kind of like m minus 1 factorial ways of sitting, right? So that is, we have to keep that in our, okay, let us keep that in the background. And let us see how many positions are left for n women. See, first woman can come and sit here, or if she wishes, she can come and sit here, or if she wishes, she can come and sit here, right? Or if she wishes, she can come and sit here. So how many such positions are there? If you notice carefully, there are m plus 1 seats are available. If you are getting confused with a general m and n, so what you can do is you take a concrete example. Suppose that there were 3 men and 2 women, then 3 men will come and sit here, right? 3 men. And how many possibilities for 2 men? 1, 2, 3, 4. So they have these 4 positions for them to sit, right? There are 2 women, and the first one can sit here or here or here or here. Second one can sit in the place where there is a vacancy. So there are 4 seats, and in the case when m places are there are m plus 1 places where this n women can occupy. If you have studied, or if you have if you have studied a little bit of permutations, then you will directly say that this is nothing but it is nothing but selection of m plus 1 positions by n women. It is m plus 1 pn, right? This is nothing but m plus 1 factorial, right, divided by what is the formula? It is npr is equal to n factorial divided by n minus r factorial, right? See, here we are not using combination. Why? Because the way in which they sit, right, the position matters here. So that is why here we are using the permutation, not the combination. Then n factorial divided by n minus r factorial, so that is m plus 1 minus n factorial. So how many total number of ways? The total number of ways is what we are interested in calculating. So the total number of ways is product of these two quantities. So that is, if I take the product, it is m factorial into m plus 1 factorial divided by m minus n plus 1 factorial. So this is the solution of the number of ways in which you can arrange their seating position so that no 2 women occupy the consecutive positions, right? In this small thought experiment which we did now, the question is why I asked men to sit at first, not women. And the second question is, where are we using this fact that there are more number of men than women, right? And how does that help us to solve the problem, right? What happens if you have same number of, or if you have more than, can you solve the problem? I mean, if you have same number of, like the number of men and women are same, or if you have number of women are more than number of men, then can you solve this problem? So such kind of questions are much interesting. You can ask them and you can try to answer. And when I did this particular product, like m factorial into, so this is also, we have this fundamental a theorem of fundamental principle of counting, right? So I use that fundamental theorem of counting, which tells you that if you have two shirts and three pants, right, then in how many ways can you wear them? I mean, different in how many ways, right? So it is like 2 into 3. For each shirt you have 3 possibilities of pants. So all of them will constitute different different combination of shirts and pants. So it's a fundamental theorem of counting is what basically I was using to calculate the number of ways. So at first what we did was that we saw in the arrangement of men. Then in the next possibility we saw the arrangement of women, right? And we multiplied both the quantities using fundamental principle of counting, and we obtained this particular result. Now you can think about another problem which is very similar to this. In the place of this, where I said in how many ways can we seat m men and n women in a row, in the place of row you can replace it with in a circle, right? You think about that, right? In a circle, if you want number of like men and women to sit, then how many possibilities will come? I mean, that's that problem is kind of very similar to this. There is only a slight modification you have to make in order to obtain the solution. But anyway, I think you enjoyed this explanation, and I enjoyed solving this problem when I so hope to see you in the next brain teaser. Thank you.